Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing. Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful, ubonge, lebuha, be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Welcome back, grade 9s. Now, before we answer these questions, please remember to contact us on our WhatsApp number, which is 079 right? So you are welcome to answer to your questions, your comments, or anything regarding this lesson. So now, let's look at the solutions together. So we're going to divide our corrections into two sections so that we have enough time to copy down these corrections, right? So now, number one was saying what group is sulfur in on the periodic table, right? The answer is that it is in group 16, right? Sulfur is in group 16 on the periodic table. Then number two, what are the reactants of the reaction between sulfur and oxygen, right? So the reactants are sulfur plus oxygen, right? Those are our reactants. And also we said write down their formula, right? So it is S plus O2. Then number three, what is the product of this reaction? Write its name and also formula, right? The product are, it is sulfur dioxide. And the formula is SO2. So now let's take a quick minute so that you can copy down number 1, 2, and 3, and we can move on to number 4 and 5. Welcome back again, grade 9s. Now let's continue with our corrections, right? So for number 4 required you to use the formulas of the reactants and products to write a chemical equation, right? So the chemical equation for the above reaction is S plus O2 to form SO2, right? Which is sulfur plus oxygen to form sulfur dioxide. Are we together? Then number 5. When is a reaction balanced? Right? A reaction is balanced when you have the same type and the same number of atoms on the reactant side and as well as on the product side. Right? Then number 6, tell us, is your reaction above balanced and why do you say so? Right? So looking at this reaction, right? Is it balanced and why do you say so? Right? So yes, it is balanced, right? Because the number and the type of atom, they are the same on the reactant side and as well as on the product side. So what do we mean by that, right? When you look at this equation, you have sulfur on the reactants, you have sulfur on the product side, right? You have oxygen on the reactants and you have oxygen on the product side, right? And also looking at the numbers, you have one sulfur, two oxygens, right? So that's why we say this equation balances. So let's take another quick minute to copy down these corrections. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Now, don't forget again, during our lesson, our WhatsApp number is 079-578-2908, right? Send in those answers, questions, your workbook, and so on, right? So that we can see your progress. Right. So now, the reactions of non-metals with oxygen, right? In the last lesson, we were talking about the reactions of metals with oxygen. And we said that the general reaction for the air, it is a metal plus oxygen to form what? A metal oxide, right? That's what we talked about in the previous lesson. So now today we're talking about the reactions of these non-metals with oxygen, right? But first of all, where do we find this oxygen, right? Where do we find this oxygen? Remember, oxygen is in the air around us, right? The air that you and I breathe in and out, right? Oxygen is all over in the atmosphere, right? So it is abundant in the atmosphere. So as you can see here, we have this layer of gases, which is the atmosphere, filled with oxygen molecules, right? In the air around us. So this is where we find this oxygen, right? So for example, right, you peel your potatoes, you peel your apple, right? You leave there the peels there, and what's going to happen after some time? They're going to start to change what? Some color, right? They're going to change color to show that there's a reaction happening between that fruit with the oxygen altogether, to prove that there's air around us containing this oxygen that is highly reactive altogether. So it is a very reactive element that is ready to react with any other substance, right? So it means that it will readily react with many other substances. So now, we know that we find this oxygen in the air around us. And now today we're talking about its reaction with non-metals. So let's go back to our periodic table, right? Let me ask a question. Where do we find non-metals on the periodic table, right? Let's remind each other. Where do we find non-metals on the periodic table? So for those of you who do not have a periodic table around you, here is a periodic table, right? So let's remind each other. Where do we find non-metals? Right. So now we said that we find metals on the far left of the periodic table, right? So these ones would be our metals, right? These ones would be our metals. Are we together? They are our metals, right? They are found on the far left-hand side of the periodic table, right? So remember also our zigzag line that we've been talking about, right? We said we find what now? We find semi-metals. Are we together? We find semi-metals. Now, what we have left off here, right? Which I'm going to mark with a blue color, right? What we have left off here on the far right-hand side now. These are all our non-metals. So to answer that question, we find non-metals on the far right-hand side of the periodic table. Are we together? So this is a clearer view of what I'm talking about here. Right? So this is the list of our non-metals that we find on the periodic table, right? So we have elements such as carbon with the symbol C, nitrogen with the symbol N, oxygen with the symbol O, now fluorine with the symbol F, neon with the symbol Ne, helium with the symbol He, and hydrogen. Now, right? You are surprised as to why is hydrogen in this section, right? Hydrogen, yes, it is a non-metal, but it's on the left-hand side, right? This is because it is there as it is what? It is the first element to be discovered, right? So, but it is a non-metal. So we have others like phosphorus as well, which is having the symbol P. We have sulfur with the symbol S. We have chlorine with the symbol Cl. Argon with the symbol Ar. Selenium with the symbol Se. Bromine with the symbol Br. Kr, which is krypton, right? Kr is the symbol. We have iodine with the symbol I. We have xenon with the symbol Xe. And we have radon with the symbol Rn, right? This is the list of the non-metals that I'm talking about, right? So we're going to mention a few examples amongst these, right? That are going to react with oxygen and see how their reactions go. Right. So reactions of non-metals with oxygen, right? After I've listed those ones, right? Or after I've listed those non-metals. So a general reaction of non-metals with oxygen forms a non-metal oxide, right? But before that, remember that when a substance reacts with oxygen, we say that it oxidizes, right? It undergoes the oxidation reaction. Are we together? When any substance reacts with oxygen, right, it oxidizes. There's some addition of oxygen, right? And we say that it is an oxidation reaction. So as I've said now, that when nonmetals now react with oxygen, nonmetal oxides are going to be formed as a result, right? When we have the two reactants, which is a nonmetal and oxygen, they're going to form a product that is a nonmetal oxide, right? So that's what we mean when we say when nonmetals burn in excess oxygen, nonmetal oxides are formed. So these nonmetal oxides, they tend to have a low pH value, right? They tend to have low potential hydrogen, right? Meaning they become what? Acidic, right? They become acidic. So now think of carbon dioxide, right? Carbon, when it reacts with oxygen, it forms carbon dioxide, which then also contributes to global warming and also contributes to acid rain, right? When it reacts with the water as well. So these nonmetal oxides, they tend to be acidic as a result, right? So let's look at the general equation that I've been talking about. So we said that a nonmetal as the reactant, right? The nonmetal and oxygen as our reactants. When they react with each other, they form a non-metal oxide as a product, right? So it is the same as the one that we were talking about in the last lesson. A metal plus oxygen to form a metal oxide. In this case, it is a non-metal reacting with oxygen to form a non-metal oxide. Are we together? Right. So now let me ask this question again. Have you ever seen coal burning in air? Why am I saying that? This is because coal is a form of carbon, right? So now we're going to look at the reaction of carbon with oxygen. Carbon being an example of a non-metal, right? So if you have seen coal burning in air, I bet you have seen something like this, right? You see a bright luminous yellow color, right? To show the what? The presence of carbon in that reaction, right? Are we together? So now moving on, let's talk more about the reaction of carbon with oxygen. Yes, we said that carbon is a form of coal, right? So when coal reacts with oxygen, right? Or when coal reacts with oxygen, and it is a form of carbon, right? Remember, carbon is used as what? Coal is used as a source of fuel for many different purposes, right? You're having a bright home, you want to warm up the stove and so on, right? What happens? We use coal and we burn coal so that we can receive heat. Are we together? But this coal now, it also causes pollution and other environmental problems such as global warming, right? And this coal is one of the primary fossil fuels that we use to generate electricity for powering our industries, our activities, and our living spaces, right? So we're going to talk more about this carbon reacting with oxygen, right? So I've given you an example now to say that coal is a form of carbon, right? To show us what color do we receive when coal is burning in air. Right. So now, so when the non-metal carbon is burnt in oxygen, right? Or when carbon reacts with oxygen, carbon dioxide is produced as a product. Are we together? Carbon dioxide is produced as a product. Let's look at the equation to prove that, right? We have the weight equation now. The carbon and the oxygen reacting together as our reactants, right? As our reactants. They react with one another to form this product, carbon dioxide, right? Carbon dioxide is our product. So the carbon, when it reacts with oxygen, it forms carbon dioxide. Are we together? They form carbon dioxide. So now let's look at the chemical equation of it. So when looking at the symbol for carbon, the symbol for carbon is C, right? So it is carbon or C plus O2 to form CO2, right? Carbon and oxygen as our reactants and the CO2 as our product. Are we together? So now, we say such an equation is balanced. Who can tell me why do we say it is balanced, right? It is balanced because the same type of atom and the number of atoms is the same throughout. It is the same on the reactant side as well as on the product side, right? Let's look at this diagram to prove that. So you have carbon or C plus O2, right? Plus O2 to form CO2, right? So when counting now the number and type of atoms, right? Let's look here. We have carbon on the reactant side and on the product side, right? How many carbons on the reactant side? We have one carbon and we have one carbon on the product side, right? So when looking at the reactant side again, how many oxygens do we have? We have two oxygens, right? And on the product side, we have two oxygens again, forming this compound, which is carbon dioxide. Are we together? So the general equation here for carbon and oxygen, it is carbon plus oxygen to form carbon dioxide. Let's not forget that one, right? So let's move on with our lesson. So as I've said that, the reaction of carbon with oxygen, right? When it burns or when it takes place, it gives us a bright, luminous yellow flame, right? It is a flame that looks like this one, right? So when you remember the evidence of chemical reaction, change of color as well is what? Is evidence of a chemical reaction taking place. So in this case here, when we have carbon reacting with oxygen, it burns to form a bright, luminous yellow flame. So now, moving on to our second example, right? The reaction of sulfur with oxygen, right? So now when you remember also the periodic table and those examples of non-metals I gave you, sulfur is one of non-metals, right? Sulfur also is a non-metal. So when this sulfur reacts with oxygen, the flame now becomes blue, right? To indicate the presence of sulfur in that reaction. The flame becomes blue. Are we together? And the product that is formed now is sulfur dioxide. We have sulfur and oxygen as the reactants to form a product which is sulfur dioxide. And that sulfur dioxide has a choking smell, right? If you can smell it, it would make you choke. So let's look at the word equation for this reaction, right? As I've said, the reactants are sulfur, right? These are our reactants. Sulfur and oxygen, they react with one another to form this product, which is sulfur dioxide. Are we together? So let's look at the chemical equation of it, right? The chemical equation now, it is, think of the symbols, right? Think of the symbols of the elements, right? It is S plus O2 to form SO2, right? Which is sulfur plus oxygen to form sulfur dioxide. dioxide. Are we together? Let's look at this structure as well so that we have a clear view of what's happening here, right? So you have sulfur as one atom plus oxygen as two atoms, right? As a molecule plus oxygen to form sulfur dioxide. And also this equation, we say that it is a balanced, right? It is balanced because when you look at the type of atoms and the number of atoms on either sides, they are the same. We have one sulfur on the product side, two oxygens on the reactant side, and two oxygens on the product side. So therefore, we say that this equation also is balanced. Are we together? Right. Now, what are the uses of sulfur, right? Sulfur now is sometimes used as a preservative for dried fruits, right? It is used as a preservative for dried fruits such as dried peaches and apricots and also guava rolls and our raisins, right? So this is an example of some dried fruits that we are familiar with, right? So sulfur is used in the process of preserving these dried fruits, right? But now, remember that it is toxic as well, right? But as it is toxic, it means that very small quantities of it can be added to food to preserve the food. Are we together? So also in very small quantities, sulfur dioxide does not permanently harm a large organism, but organisms such as bacteria cannot survive in the presence of sulfur dioxide. Right. So we said that when sulfur reacts with oxygen, it gives off a blue flame, right? As you can see here on our picture, we have a blue flame to show that this reaction between sulfur and oxygen has taken place, right? Just to remind you the chemical equation, it is S plus O2 to form this SO2, which is a gas, right? So now, let's quickly move on to activity 1, right? So we have activity 1 here, which I'm going to go through with you in terms of questions. Number 1 reads as follows. It says, write down a balanced chemical equation for the reaction between sulfur and oxygen. Then number 2, name each substance in your equation. For number 3, complete the following equation, right? Non-metal plus to form non-metal oxide. So I'm going to give you 5 minutes quickly to copy and complete this activity. Then after that, we shall continue with our lesson. Welcome back, grade 9s. I hope you enjoyed this activity, right? We're still waiting for your answers, your comments, or any questions regarding this lesson, right? Remember our WhatsApp number 079 So let's look at the solutions together now. Right. Number 1, write down a balanced chemical equation for the reaction between sulfur and oxygen, right? And the equation is S plus O2 to form SO2. Then number 2, name each substance in your equation, right? The substances are sulfur, oxygen, and sulfur dioxide, right? Then number 3, complete the following equation, and you already have the answer there, right? It is non-metal plus oxygen to form a non-metal oxide, right? So I'm going to give you a quick 2 minutes to copy down the corrections, and after that we shall resume with our lesson. Welcome back again, grade 9s. Now let's explore one more example of the reactions of nonmetals with oxygen, right? Which is the reaction now between hydrogen and oxygen, right? Remember also hydrogen is a non-metal, right? So hydrogen and oxygen can also react spectacularly. Are we together? They can react spectacularly, and as well as the reaction between a large quantity, right? A large quantity of hydrogen and oxygen in the air produces a beautiful orange fireball and a very loud pop sound, right? A loud popping sound like boom, right? Let me show you this example, right? Which is now we have a balloon here, right? The balloon is filled with what? With hydrogen, right? This balloon now is reacting with the air around it, which contains oxygen, right? And we have this candle here to give us what? Some light, right? So when they react with each other, the sound goes like boom, right? When it goes like boom, you have now what? Products such as water vapor being released, right? Water vapor in the form of H2O being released, right? Why am I saying H2O? Because we have 2 hydrogens on one molecule and 1 oxygen, right? Two hydrogens and 1 oxygen in one molecule of that water vapor. Right. So let's look at the chemical equation for the above reaction, right? So the chemical equation here is 2H2 plus O2 to form 2H2O, right? And we say this one is a balanced equation, right? Why do we say it's a balanced equation? Because if we were to count or look at the elements that we have there, they are all the same and the numbers are the same on either side, right? So looking at the reactant side, we have 2 multiplied by 2 to give us 4 hydrogens, right? Also here 2 multiplied by 2 to give us 4 hydrogens. Altogether, O2, we have 2 oxygens and 2 multiplied by 1 here to give us 2 oxygens, right? So that's why we say this equation is balanced, because the number of atoms and as well as the type of atoms are the same on the reactant side as well as on the products side. So this is the weight equation for the above reaction. It is hydrogen plus oxygen to form hydrogen oxide, or what we call water. Are we together? So now let's move on quickly to activity 2. Right. So if you remember our previous lessons, right, we have talked about balancing of equations, and in this lesson we have talked about carbon dioxide, right? So I want to test your knowledge in terms of balancing equations and what we have talked about in terms of carbon dioxide today, right? So number 1 says, how many carbon atoms are on the left hand side? Left hand side is our reactant side, right? How many carbon atoms are on the left hand side are required to form 5 carbon dioxide molecules on the right hand side, assuming that sufficient oxygen is available. Number 2, how many carbon dioxide molecules will form on the right hand side if 10 carbon atoms are used on the left hand side, assuming also enough oxygen is available? Number 3, how many carbon dioxide molecules will form on the right hand side if 6 oxygen atoms are used on the left hand side, also assuming that enough carbon is available? Then number 4, write a balanced chemical equation for the reaction of sulfur with oxygen, right? So that's all for our activity. I'm going to give you 5 minutes to complete this activity. Then after that, we shall mark together. Welcome back again, grade 9s. Now let's mark together. Number 1. How many carbon atoms on the left-hand side are required to form 5 carbon dioxide molecules on the right-hand side, assuming that sufficient oxygen is available, right? How many? How many? 5 carbon atoms, right? As long as you know the ratio between what? Or the ratio of carbon dioxide. For every carbon dioxide molecule, there is 1 carbon and 2 oxygen molecules. Right. Number 2. How many carbon dioxide molecules will form on the right-hand side if 10 carbon atoms are used on the left-hand side, assuming that enough oxygen is available? Right? How many? 10 carbon dioxide molecules, right? Because we have 10 carbons, it means we're going to have 10 carbon dioxide molecules. Number 3. How many carbon dioxide molecules will form on the right-hand side if 6 oxygen atoms are used on the left-hand side, assuming that enough carbon is available, right? And those are 3 carbon dioxide molecules, right? Because for each and every carbon dioxide molecule, there is 2 oxygens, right? So meaning this 6 is divided into 2 to give us 3 what? Carbon dioxide molecules. Now, number 4, write down a balanced chemical equation for the reaction of sulfur with oxygen, right? And the answer is S plus O2 to form SO2, right? Sulfur plus oxygen to form sulfur dioxide. So I'm going to give you a quick 2 minutes to copy down the corrections. Then after that, we're going to summarize what we have learned for today. Welcome back again, grade 9s. Now let's summarize what we have learned for today. So today's topic was on the reactions of non-metals with oxygen. Are we together? The reactions of non-metals with oxygen. So let me take you back to our previous lesson again. So in the previous lesson, we were talking about the reaction of metals with oxygen. So we said that their general reaction of metals with oxygen, it is a metal plus oxygen to form a metal oxide, right? Having the metal and the oxygen as our reactants, then the metal oxide as our product. So today also, the general reaction of non-metals with oxygen, it gives us a non-metal oxide, where you have the non-metal plus oxygen as our reactants, forming a non-metal oxide, right? So we said that when any substance reacts with oxygen, it oxidizes, right? Undergoing an oxidation reaction. Are we together? So yes, we said that nonmetals react with oxygen to form nonmetal oxides, as I've alluded. And we said that also the nonmetal and oxygen gas are the reactants type of reaction, and the nonmetal oxide is their product, right? Also, we said that the reactions of carbon and sulfur with oxygen are examples of nonmetals reacting with oxygen, right? And carbon and sulfur, they both form dioxides with oxygen, but this is not true for all non-metals, right? So we said that the general equation also is, let me write it down, non-metal, right, plus oxygen to form what? A non-metal oxide, right? That is the general equation of non-metals reacting with oxygen. So also to summarize this in a form of a concept map, we said that the reactions of non-metals with oxygen happens during burning, right? Happens during burning, and that burning is called what? Combustion. Are we together? So some non-metals, they react with oxygen to form what? A non-metal oxide. And we're talking about non-metals such as carbon and sulfur, right? Carbon reacts with oxygen to form carbon dioxide, right? And as well as sulfur reacts with oxygen to form sulfur dioxide. And also in our example that we explored, the hydrogen reacts with oxygen to form hydrogen oxide, or what we know as water. And that is all for today's lesson. So in the next lesson, we'll be talking about acids and bases. So you know the drill by now. Go home, open your textbook, take your time to study about this topic, so that when we come back, it is an easy learning and teaching process, right? Go learn more about acids and bases. Until we meet again, from me to you now, thank you and goodbye.